Passage 4 is not a conflicting viewpoint, so we're going to go straight into the questions. According to figure 2, so figure 2 is right here, the maximum positive value of Vs was approximately, so Vs is the dotted curve. The maximum value is up here, positive is about 0.25. But it's also, if we look at our answer choices, it's all V, so voltage, so that was current. This is voltage, so we're going to come over to the voltage of 250. That will be C. 22, a period is the time required for a wave to complete one full cycle. Based on figure 3, the period of VL was, so VL is the dash line, so if we, or dash curve. So if we look at the beginning, it's going to start at a maximum, it's going to go down, and it's going to also come back to a maximum. So it's done one full period at 20 milliseconds. So the answer is H. On 23, according to figure 2 and 3, so comparing these, which voltage varied the least during the 20 millisecond interval? So if we're looking at, we have Vs, which is going to be in figure 2, and then VR, VL, and VC are all in figure 3. So if we look at these three, we can see that between those, very less would be the dashed curve, so that's going to be VL so far. So we know it's not going to be VR or VC, but we have to compare it to VS. So to compare it, we look at the maximum to the minimum, because the scales are different. So the voltage for VS is going to go from positive 250 to negative 250. Whereas in VL, we're going to look at VL, it goes from 50 to negative 50. So VL is definitely going to be a smaller variation than VS is. So the answer for 23 is C. Question 24, polarity refers to whether a voltage is positive or negative. So a voltage of 0, V has no polarity and can be ignored. So based on figures 2 and 3, which two voltages were always opposite in polarity? So one is positive while one is negative. So opposite in polarity is one's positive, one's negative. So we can look at our answer choices. F says VR and VL. So if we look at VR and VL, which is the solid and dashed, so we can see at the beginning, they're both in the positive. So that's not always opposite. So it's always opposite. VR and VS, which are going to be in two different figures, so I'm going to skip that one for a moment. VL and VC is the dash and the dotted. So I'm going to look at the beginning. I have the dotted is in the negative, and then the dash is in the positive. Then it comes to 0. And then I have the dash in the negative and the dotted in the positive. Then it comes to 0. Then I have the dotted in the negative and the dash in the positive. So those are actually always positive and negative. So H so far is good. Then we have VL and VS. So VL is the dashed and VS again is the in this figure as well. So we can pick a point for the VS's at, let's say, 8 seconds. It is in the positive. So for VS, at 8 seconds, it's in the positive. So at VR, the solid, at 8 seconds, it is also in the positive. So those are not opposite of each other. And then for VS and VL, so at 8 seconds, the VL is the dashed. At 8 seconds, it is in the negative. So that one so far is okay. But I can pick another one because I want to see if it's always going to happen. So for the VL, the dashed, I have it in the positive until it reaches about 5 seconds. So this is in the negative until it reaches at 5 seconds. It is now in the positive. So it's positive and positive for around 4 seconds, or a little bit more, between 4 and 5 seconds. So these do not always have opposite polarity. So the answer for 24 is H. Question 25, based on figure 2, which of the following times was the current in the circuit, so the current in the circuit flowing counterclockwise? Okay, so counterclockwise, let's look at some information up here. We have counterclockwise either clockwise or counterclockwise, negative current. So this means negative current. And if we're looking at the current in the circuit, so we're looking at how the I amperes, so the current shows how the current in the circuit, so we're looking at the I and amperes A, so we're looking at the current. When is it negative? So figure 2, when is it negative? At 0 seconds, we're looking at the I, we're looking at the solid. So at 0 seconds, it's neither. At 5 seconds, it's in the positive. At 10 seconds, it's at neither. And at 15 seconds, it is in the negative. So at 15 seconds, it will be in the negative, so that answer is D. Okay. Question 26. The table below lists the electric charge in microcoulombs stored at the capacitor at 3 different times during the 20 millisecond interval. Based on figure 2 and 3, from time t equals 7 through time equals 13, so we have 7, 10, and 13, did the charge on the capacitor more likely change in sync with I or VC? So if we look at 7, 10, and 13 for I, 7 for I is going to be about here, 10 is going to be about here, and 13 is going to be about here. So it's going decreasing. It looks kind of like this. Then for VC, because we're looking at VC, which is this dotted curve, we want to look at, again, 7, 10, and 13. So 7 is about here, 10 is up, and then 13 is about here. So for VC, it kind of looks more like this. So if we look at the charge, we have 0.51 to 0.87, and then back down to 0.51. So it's definitely going to be VC. So it's not going to be I. So F and G are gone because they don't match. So we read the rest of it. Over the time interval, both the charge and VC decreased and then increased. So did this go down and then up? It did not. Did it increase and then go down? So did it go up and then down? Did this one go up and then down? Yes. So the answer for 26 is J.